Thank you for staying until the end. I have the honor to finish the conference, to be the last one. And the information I am going to show you will be a good impetus for you to learn something you don't know at the moment. In general, the presentation is called Engineering Art with Revit, Rhino, and SOFiSTIK. The art means that it has some unique features that you can use even sometimes you don't even know about it. You don't even imagine they can exist. I have 6 questions. The general questions, how SOFiSTIK does work. We didn't speak about that at this conference. Then point 2, is SOFiSTIK a BIM tool? Then what about Apex? How do we work, our Apex Bureau? What is the point here? Why do we solve the problems quickly without going into detail, but I'll show you the general direction. And 3 specialized questions. How to model complex geometry, how to solve geotechnical tasks without using any specialized tools, and to complete, how to use SNPs and other rules, how to comply. Then SOFiSTIK. I'll show you diagrams, you can have a look. They are basically to let you know how it works. SOFiSTIK, the main thing there is a database. The database contains all data about model, about calculation results, and all adjacent information. The database is structured. Each element is in a certain square, in a certain cell, and it's indexed. And you can get access to this cell by any tool. You can use API, you can use any other access tools. Then you can read, you can write through SOFiSTIK, and you can process. Interaction in SOFiSTIK looks like that. There are some of the modules. This is not all, but it's the general picture, just for you to realize. When you develop a model in Revit or SOFI Plus, WinTube, Rhino, you then load it into a database. Actually, all questions after the presentation. So, Revit, Rhino, make your model, develop your model, then press a button, export, and the computer starts thinking and then launches SOFiSTIK MPS. And it generates a CAD-INP code, which you could write manually yourself. But all the models are transformed to CAD-INP, and then CAD-INP launches a model, any model it needs. The modules just take information, processes it, and makes entries into a database. And then we store the information in the database. And there is one important point, the green line. From the database, you can upload information back into Revit, Rhino, WinTube, SOFI Plus. For instance, in SOFI Plus, you can open any schema. You can develop it in Revit and export it to SOFI Plus. From Rhino to SOFI Plus. You can open it in WinTube as well to read. In Rhino, you can download information about finite elements. You can clean the mesh, if you like. It's very simple. And CAD-INP helps you to manage post-processes. To begin with, you can program or configure a report. For example, all reinforcements in 4 directions. And it just gives you 100 sheets or 200 sheets, and you don't have to press a button each time. You'll get everything at one touch of a button. AutoCAD, SOFI Plus, everything can be generated for the database. You can see different steps. AutoCAD, Revit, Rhino, you create a model. Through interfaces, you can define appropriate calculation characteristics, rigidity, loads, everything. Then, the interface itself generates code in CADINP, then SOFiSTIK MPS processes it all and enters the result to the database. This is the API scheme. If you like, you can go into detail. I'm not going to explain it. CADINP, C++, C#, interaction scheme is the same. Now, SOFiSTIK, is it a BIM tool? First of all, you have to ask a number of other questions. What are the criteria for the BIM tool? The first one is 3D. Availability of a 3D model. BIM proceeds from the fact that you do have a 3D models with parameters or properties of elements. In Revit, we have the model, but what about parameters? We can add it, we can read it, we can enter specifications. That's important. One more point is a structured information base of the project and the capability to read parameters and share them. If the product is self-centered, if it cannot share, if you cannot export, then the tool cannot be regarded a BIM tool. So BIM of the second level requires interaction and sharing, collaboration. Any information must be taken from the model, you know how to address it, and then record appropriate information as well. SOFiSTIK complies with all those criteria. Revit, SOFiSTIK, and the whole range of products of SOFiSTIK tools, development in Revit, develop extension in SOFiSTIK, you can analyze, you can design, and then give it back to Revit. We have appropriate plugins, SOFiSTIK FEA extension and SOFiSTIK reinforcement generation. The first for export, the second one for import. I'll show you some of the capabilities of Revit and SOFiSTIK, and you will assess or evaluate the quality. Look, we have a slab, a wall with certain openings, beams of different shape, some slabs with openings and various surfaces, ridges. Then you can define the rules. You can define how the element is going to work. Will it absorb the load? Will it bend? If you tune the template in Revit correctly, then you can automatically find the material. The material will be picked up from SOFiSTIK database according to your parameters. The same with sections. All the sections defined in Revit can be analyzed in SOFiSTIK. Of course, some clearance, some details may be required, but in general it can be processed. Linear elements must be defined. We export the model, hinges, pivots. So you can see everything I showed you. Curved walls and everything is there, some of them hard, non-bending openings, holes, T-shaped structures. All information is there, including reinforcement, its sections. So that is hardening. Now, the loads. I have different kind of loads, complex loads, continuous, non-continuous loads, load distribution. So action is here, I export, and in WinGraph I can see what I have now as a result. So the loads can be described as applied to elements, not those I entered, but those that were generated and they are applied to my elements. For example, in a slab, which I showed you, you have this kind of loads, X, Y, Z, in different directions. The holes, not, well, you can see that everything can be exported and imported. So in this load distribution area, all the loads can be collected and distributed across the finite elements. Then, if we expand those capabilities, we do make some experiments. In Apex, we have our own plugins, including this one. An interesting one, actually. In version 17, you can use analytical surfaces, not volumes, but spaces, as they call it, calculated elements, and it can be reflected in analytical models. You can take coordinates and with our plugin generate the KDIMP code, and then with tools of search of maximum parameters or border parameters. I'll show you specific example. CFD export. From Revit, it can be exported, and something my colleagues have shown. Igor, for instance, export of ropes from Revit. How do we work? A few words about ourselves. How can we support collaboration in SOFiSTIK? We don't have much experience locally and internationally where we can standardize calculations and realize what is the sequence, what kind of results we can obtain. Even if you make two people work with two computers and give them the same task, the same software, you will have different results. Within appropriate limits, of course, but the results will be somehow different. To minimize human factor, we need certain templates. To do that, we must have rules, numeration, indexation rules of materials, groups, effects, loads, combinations of loads and efforts, and so on. I'll show you what we do. It was allowed for me to show you our experience, so if you like, you can do it yourself. We have our own numbering rules and indexation rules. Loads combination, efforts combination, results, and calculation cases. In general, in SOFiSTIK, you do have numbering rules. If you read The documents, the rules are there in SOFiSTIK. You have them. Unfortunately, we didn't like them because our approach is a bit different and we developed our own numbering. But if you like, you can use the SOFiSTIK default numbering. Using templates help you to think about your job without thinking about numbering. So you just do your job as an engineer without thinking of how to index, what kind of numbers are used. You just press a button and the numbering is done automatically. The numbering of efforts, loads, cases, everything can be automated quite easily, and the engineer should not spend his time and effort to pay attention to numbering. It can be done and must be done automatically. We use templates for SOFiSTIK based on SSD MDA in CADIMP, database, algorithms. Each template is quite light, 100 kilobytes only, but it does a job which sometimes an engineer does when he uses different types of software. Those templates accelerate your work by 5 times in some analytical works. I tried to assess it myself. That's what I have seen. And when our colleagues start using templates, they're very happy. They think about their job only, about their design. All the rest is done automatically. Calculation is done, they see the result, the process is automated. A small secret, all parameters are in those codes. There is a window where you enter all indices for rigidity, for calculations, all data about loads. A lot of parameters are taken by default. All the rest is entered, then calculated, processed, and you have the result. Let's have a look. Let me take one real project. You have seen it before, Prime Park, Avia City, a huge complex, 480,000 square meters in one file. Let me show you. So this is a huge complex, 480,000 square meters, one file, no limits, 200 megabytes only, all analytics, all loads. Thanks to optimization, so I'll give you an example of one block. So this one, actually, all analytics, all loads, our plugins, temporary and continuous, static, pulsation, wind, snow, rain, everything. So we save it in a special folder, apply a number, then a linkage in SSD. We create a project by a template and save it in the same folder with the same name. Then Revit will automatically use the database and you can do mapping automatically without resorting to additional modeling. So what do we have to do in Revit additionally? Materials, mapping, everything is there. Whatever we have in Revit, we have in SOFiSTIK. I'm not going to change anything. Of course, we can specify the reinforcement rules, but let me leave it as it is. Loads are coordinated, and well, what I have to do is, well, it's our panel of workforce management. Wind load, I wanted to show you. It's really a good module. And I can tell you more about what we do about the wind. For such rectangular buildings, we can provide wind load as a static and calculate it without dynamic indices. And then this constant is specified in SOFiSTIK. First, analysis, load, frequency, oscillations, and the pulsation, the oscillations by SNP is analyzed to calculate accelerations properly. So this is the model. So I show it briefly without losing time. Nothing is cut, nothing is deleted. I show you whatever we have, trying to accelerate some of the points. This is the model, the graphics, the materials, different groups of elements. Let me now calculate the model. Let's calculate.
And to do so, I will need the following. I need to define parameters, and I don't think it's a problem. So we specify coefficients, factors, formulas, and concrete types in order to choose the right reinforcement, and geotechnical data for geotechnical analysis for elastic half spaces. The developers put a lot of effort into improving that module. It was a huge effort, and by the joint effort we could achieve very good results. And here we can analyze any volumes, even 2,000 or 3,000 of piles, and calculate elastic half spaces. We can do that very fast, and when we compare it and double check, then the results are can be trusted. So verification shows that it's a very accurate result. So that's how we do it. Now I will scroll a little bit, because here it's about parameters, setting parameters, soils, again soils and soils here, and here I change the thicknesses of soil layers. It's an interactive table of a kind, as one vector array. Well, that's the best solution we could find. And I think that we need to create our code, but unfortunately, it's not. We can create our own SSD, our own interface. So let's analyze it. And here, many calculations will run here automatically. Boundary conditions will be assigned, and loading factors, and linear calculation, model calculation with all aggregated masses, and long-term loads, and calculation of critical aspects and stability losses. Here you can see the whole spectrum of results. So without long adjustments, I can see all the results just by push of a button, and without going to any other windows and too many clicks. And if you want to have a combined calculation together with building a structure and soil interaction, you can calculate wind load, and you can use half spaces for vertical loads. I have many settings, and I can check materials and cross sections, dimensions, and then I check loads, deformations, accelerations in both in all directions and normal forces in structures. Here, linear half spaces. Here you see how it goes. The calculation is run in iterations to improve quality and to speed up the calculation. And if you're interested in half spaces, it's saved in database. Those working with face module know about that, so you can obtain those geotechnical. Well, I made a mistake with coordinates, and well, but it's okay. And here we see we use a code to get some surrounding areas, and we can see the bed factors and design load. Now we can calculate and perform the other types of analysis. This video is quite long, but now let's take a subsystem. It is possible to set up a hierarchy. You have main system, but you can select some elements, for instance, this slab, and I can calculate this story separately. Maybe I need different materials and combinations, and I use a template. This one is smaller. This template is smaller than for the entire building, and I can export data to the database. So I create a template and I export data. Now the generation process starts. And now I can open SOFiSTIK, and I open a slab. Every slab, every element, and I can work individually with them, and everything comes from the same Revit file. So I can create different databases based on a single Revit model. I rework and update the database with boundary conditions. After that, the system suggests that I stop and create RCN. RSN, it's the Russian abbreviation for design analytical load combination, to set up load combination. Some of them are for long-term loads and some for temporary loads. These are used for different scenarios. And now I set up reinforcement, some minimal reinforcement bar settings. And then we select. And now I will have prepared graphic representation. You don't need to enter any values, so just push a button and all the information is there. Geometry, bendings, and geometry, and reinforcement in all directions, and reinforcement of beams, lateral beams, transversal beams mostly. And I will add to the presentation of Igor. I asked him to record a video about one of the buildings for spans of 12 meters. It was a design option. It wasn't approved, it wasn't chosen as the final design, but it was very interesting to solve this engineering problem. So we selected these bundles of reinforcement tendons. And we don't need to search for starting points. For residential buildings, for just civil structures, you can create your code that can be generated in SOFiSTIK after the export of those tendons. The tendons have all the parameters that are needed for the calculation in tendon module, and we use our plugin to translate these tendons into analytical model in SOFiSTIK. So now I export the tendon. I simply add the tendons to the model. Here they are, pre-tensioned tendons in slabs. And one push of a button and calculation runs. After that, we can view results and check the progress. And now the calculation is finished, and we can view results, and we can check the forces applied. And again, I would like to highlight once again that we have an end-to-end solution for BIM, and we can use the SOFiSTIK results. We can export them into DWG file, and we can use this plugin, and we can transfer results from WinGraph to DWG. I don't know why developers didn't do that, but we can use DWG with colors and vector form. Everything is perfect. And we upload them as links, as external links, and we can see highlighted areas where reinforcement bars are necessary, and the design and engineering people can add everything necessary. Here you can see several projects performed by Apex. There are many more of them, but the most interesting ones are here, and you can learn more about them on our website, apexproject.ru, and you can read up what are these projects, how we participated in those projects. Of course, we analyze each building separately. It's not necessary to export everything to SOFiSTIK and calculate everything at once. And now we are going to specific questions. I hope you're not very tired. I'm going to discuss the plugins, and many of you might know that it's popular now to use parametric modeling, Bionics. Many use Dynamo, and some of you are, who uses Dynamo? 2 people, 3, 4, perfect. That's great. Rhino has Grasshopper. Those of you who know Rhino must know Grasshopper, because they're inseparable, and you can create complex geometry in AutoCAD. It's in AutoCAD. Some form created by shells, curves, and extruded. And I want this curve to be a calculation element of SOFiSTIK. I select them, and the same goes for rod element. Now let's make them bearing structures and set up dimensions and cross section. And now that's what I do. Ready. I press export. I have a second screen. That's why I need to drag and drop for the presentation purposes. So it's a model that has been generated from AutoCAD with very, very dense mesh. Well, it was a big model. And I will use Dynamo to show it, because you can create very complex geometry. You might have noticed that in Russia people like twisted towers. It's very fashionable right now. So let's take this structure with lines, with slabs, and Dynamo enables me to set up the algorithm for sequencing, and it's up to you to decide what you need. You just need algorithmic thinking. If you understand what has to be done then, and if you understand that with each story the column is twisted by 3 degrees, you can set it up, and the model can be updated on the fly. It doesn't look very nice. It was a very fast exercise, so just to show it. Of course, it can be done in a very nice and beautiful way, but it's just for the presentation reasons, so it's a simplified model. And we check boxes to enable analytic model if we want to. Now I will assign parameters of SOFiSTIK groups. I can use properties to do so, or I can write a plugin, like we did in this case. And now I send everything to be calculated, and now I'll check what's there in SOFiSTIK. I'll use a template to do so. With the same name as the Revit file, I save it, and here I will change the boundary conditions a little bit. Rigid connections from the bottom, it says comment and uncomment. Comment one line and uncomment another line. And here are cross sections, dimensions, and I try to create an even mesh without too complex areas with very dense finite elements. So here I can calculate. This tower can be extended. There is no stiffness core, and that's why it expands a little bit. We use Karamba. It's a module for statistical calculation of complex curved shells. And if I have an oval that is twisted, which is twisted and has certain form changes in the very middle. So that's the model that I can change, and I can run a calculation by using Karamba plugin. I add model for output and the calculation. Here I have the loads, and I can check for deformations, longitudinal stress. My computer is working too slow. I can slightly decrease the deformation, so that's the form. And it can be calculated and can be analyzed in SOFiSTIK. You need to use Bake to create a model in SOFiSTIK. So now I'm showing the elements of Rhino, and I can assign SOFiSTIK properties to it. It's structural curve. These are structural curves. I can define cross sections and set up how they work, how these elements work, and save the model for analysis. After that, I export the model. It will think a little bit, and now I have this model. So this connection works brilliantly, and it's a real project. It was one of the tenders that we participated in. Can you guess what it is? It's a bearing column made of architectural steel in Rhino, very complex geometry and with mesh for analysis. So if you have similar engineering problems, you can solve them by using these two products. So besides, you can define loads and ask SOFiSTIK to find the optimum geometry in order to optimize material consumption. And SOFiSTIK can use form finding of different kinds. You can find forms for membranes, for rigid structures, for instance, a slab, and poles, and we need to find perfect form. And there is maybe you recognize it. It's the cover for the British Museum. In SOFI Plus, I have a 2D form. My colleague had a presentation on form finding in one of the previous conferences, and now I export those elements with loads, and as a result, I get a flat form. And let's do it with negative. And now find me form for this load. So now I see that that's the deformation that's going to be. And now let's save this form, and I will use this form as an analytical form. And after that, I can analyze this form. So it's great. So I get optimal form, and it works the way you need to. So form finding capabilities have no limits. It was I was very pleased to find out about that, and I checked several options, and you can find a structure that works only with the actual loads and have no bending loads that are more deforming, and then it's up to construction guys to be able to build such structures. That's another story. For the following engineering problems, we use the following way of work. I save a DWG file. I use a template for retainment wall. I save it to the same directory where my AutoCAD file is located. And here I have a scheme again, defining parameters, setting parameters set up, like in hardening soil or different models. I won't comment on the results, so this table contains all of the most important parameters. Here you can see some of the examples. We need to adjust. We need to know the length of certain elements in order to define the stiffness, and we can model additional support elements. So here we go. All of the parameters. And here I have materials, all the interfaces, and the code runs smoothly. After that, I assign work areas. I define materials, so for this area IG1, after that IG2, IG3, and so on. I start drawing the soil. And now add attribute area, and now what do we need for earthworks? So it's the first stage, stage number 2, group number 3, third stage. And then we go to the here we have the possibility to set up the interfaces. And that's all. And that's the scheme with all values. After that, I assign boundary conditions from the hinged and rigid on the bottom, and here we can deform it. That's all, or have I stopped it? Just a second, I'll check the video, sorry. I'll try to run the video again and reach the point, the frame where we stopped. So after that it's clear, it's exported, that's my model. And now I can check for each stage and can calculate the stability of this retainer. And all calculations for each phase, for all stresses, for all forces. 3D soil can be done only with this areas, so you can model it here. Let's imagine I have this picture, and here I have already some shells. Here they are, and stiffening elements, strengthening elements. I need just the shells to get a closed volume. If SOFiSTIK, so I can create 3D with CAD-INP, and there are no limits to that. And besides, there were some red points. Those were structural points, and I use them to find coordinates for volume mesh. And boundary conditions. And here I see that it's a code that defines where the points are that I need and which materials we apply to them. And as you see, it's just a perfect solution. So this mesh is 3D, and that's how it looks like. Now we don't have group 99, now we can calculate phase by phase, construction sequence, and with retainment wall, with foundation bed, and so on.
Without using Wintel. 1, 2, 3, stage 1, 2, and here Here you are. At this point, my videos are over, and a few words in the end. That is something we face when using SOFiSTIKs. So there are some requirements. The interface is not always evident. How to act, what to press, what to use. The Russian users are used to the products with a clear sequence of events. Stage 1, Stage 2, Stage 3. SOFiSTIK is different. It's up to you to define the approach, and you can work the way you want. Here I can tell you how to take into account local SP requirements by standard means. For example, RSU calculations, how to do it correctly in statistics to comply, SOFiSTIK to comply with Russian requirements. Eliminate simple in group 1, group 2. They look more like the requirements of SP, and well, when you build the rules, or RSU rules, choose the loads and the effects when you switch on group 2. So always put 1 in the load field by default. Secondly, please indicate the type of load: short-term, long-term, constant, temporary, wind, snow. When you want to reduce the load, then you have to take all that variety. For example, for short-term only, it's lower. It's 0.3 only, or 0.35, but only for this kind of influence, without wind. So create several types of requirements for different types of loads. Joint loads, mutually excluding loads, and besides, you have to divide them with due regard of the later calculation. So, for example, if you have a slab, you have to use group 1 combinations. In preposition, I recommend not to include all search methods, especially if the mesh is not of high quality. Use only the latitude and longitude. You don't need anything more than that in RSU. Longitudinal forces, and there are a lot of other parameters or effects which are not necessary. First of all, you will accelerate the calculation, and the results will be similar to those that you can reach manually. Wind pulsing, wind oscillation. In SOFiSTIK software, load can automatically apply such loads and distribute them. We have 2 modes. One is average wind pressure, and second is peak wind pressure. So if we take that peak is like this, without reaction or dynamic reaction of the building, then you can have it as a first iteration, and then through a simple code we can do it as you can see here. 3 forms of oscillations and maximum and minimum effort, nothing else. 10 minutes to go. Reinforcement, new requirements say that we have to take into account nonlinear tasks, statistical. Okay, if you do that, I can show you the structure and the loads. For example, linear calculations, ASE, maxima, RSU, then first group, second group. We have it statistically. Then you develop RSNs, group 1, group 2, for nonlinear approach, and then you calculate nonlinear with renewed rigidity, with reinforcement, with linear statics. Two groups again, refresh this data and calculate it, correct the reinforcements, but that is already a specialized analysis, SLS and so on, group 1, group 2, nonlinear calculations. In general, you can get good calculations, including each and every reinforcement rod, easily, depth of fractures, everything interactively in a graphical mode. That's all I wanted to say. I hope that was interesting. Thank you, Andrew. Very fast, very professional. So each of us have to evaluate. We have just 5 minutes to questions, if any. Welcome. I think if you have no questions, then everything was quite clear and concise and compact. It was a real master class in all respect. Well, just one point. Since you have no more questions, I want to announce something. We're going to share experience in SOFiSTIK and also in BIM. If it's interesting, FSS invited us to BIM in Practice 2017 in St. Petersburg. We'll talk about interdisciplinary interaction inside the project team, how to collaborate with the help of BIM. Well, a small announcement. Thank you very much indeed for your patience, for your participation, and wish you all the best. I would like to thank the companies, Apex, PSS, and SOFiSTIK who organized all this. I wish you well.